Hello and welcome to this video about the Interface Segregation Principle, one of the solid principles of software design. In this video, we will discuss what the Interface Segregation Principle is and how it can be used to improve the design of our code. The Interface Segregation Principle, or ISP for short, is one of the solid principles that helps us to create more modular, maintainable, and testable code. It states that clients should not be forced to depend on interfaces they do not use. In other words, it's better to have small, focused interfaces than large, monolithic ones. This makes the program easier to debug for three reasons. 1. There is less code carried between classes. Less code means fewer bugs. 2. A single method is responsible for a smaller variety of behaviors. If there is a problem with a behavior, you only need to look over the smaller methods. 3. If a general method with multiple behaviors is passed to a class that doesn't support all behaviors, such as calling for a property that the class doesn't have, there will be a bug if the class tries to use the unsupported behavior. Now let's look at a sample code that deals with shapes. Suppose we have an interface called iShape that represents different shapes, and it has three methods: draw, getArea, and getPerimeter. We have two classes that implement the iShape interface, rectangle and circle. However, both of these classes implement all three methods of the iShape interface, even though some of the methods are not relevant to them. For example, the rectangle class has width and height properties, so it can calculate the area and perimeter. However, the circle class only has a radius property, so it cannot calculate the area and perimeter using its properties alone. As a result, the circle class has to implement the getArea and getPerimeter methods using the radius property, even though they are not relevant to circles. This violates the interface segregation principle because the iShape interface is too broad and includes methods that not all shapes need. Clients that only need to draw shapes, for example, will have to implement unused methods or throw exceptions, which makes the code less modular and harder to maintain. To apply the ISP to this code, we can split the iShape interface into smaller interfaces that are more specific to each shape. For example, we can create an interface called iRectangle that has methods for calculating the area and perimeter of a rectangle. Similarly, we can create an interface called iCircle that has methods for calculating the area and perimeter of a circle. Now we can modify the rectangle and circle classes to implement the appropriate interfaces. The rectangle class will implement iRectangle, and the circle class will implement iCircle. This way, clients can depend on the specific interfaces that they need, and they don't have to implement unused methods. In conclusion, the interface segregation principle is an important principle of software design that helps us to create more modular, maintainable, and testable code. By creating small, focused interfaces, we can improve the design of our code and make it easier to work with. Thank you for watching.